Hi folks, this is Steve with Disruptive Software. In Chapter 3 of the iCanScript Space Shooter tutorial series, we are going to learn how to create hazards and explosions. Our player can now move around the game area and shoot. Let's continue by creating hazards for our player to shoot at and avoid crashing into. We will create a visual script for the prefab called Astroid. Just like the bolts we used for shooting, there may be none, one, or many asteroids on the screen at the same time. So we can't just create one in the scene hierarchy, but we'll create a prefab that can be instantiated in whatever number are needed, and then destroyed when they are shot down or leave the play area boundary. To begin with, find and select Astroid in the prefab folder under the Space Shooter project. Let's add a visual script to this prefab. For this case, we don't need the update message handler, which is created by default. Go ahead and delete it. Instead, our logic will be in the start message handler. We want our asteroid to automatically move down the screen when added to the scene, just like the bolt moved up the screen. Let's reuse the mover logic we created for the bolt. Select the bolt prefab. Here is the mover logic. Let's put it into a package. Just select each of the three nodes using multi-select by command-clicking on a Mac or control-clicking on Windows. Now right-click and select Wrap Multi-Selection in Package. Let's call this package Mover. Let's also move the velocity scale port to the package interface and call it Velocity by clicking on the label and changing it. Now, how can we reuse this bolt package in the asteroid? We can use an iCanScript concept called snippets, which are similar to cut, paste, and modify for textual code. Shift-click on the mover package and drag it into your prefabs. We now see our mover snippet down here. Go back to the asteroid prefab and drag the mover snippet into it by clicking and dragging. Now connect the ports external to the package. The velocity of 20 was for the bolt. Unlike the bolt, the asteroid should move more slowly and move down instead of up. Let's change it to -5. Now, let's test it by dragging it into the scene. That kind of works. But we can notice a few issues with the asteroid. It just falls without tumbling around like a real one would. It always falls from the center of the screen. It does not destroy our ship when it collides with it, and it's impervious to our shots. We will have to add additional visual script logic to handle each of these issues. One thing it did do is get removed from the scene hierarchy once it fell off the screen. How did it destroy itself? Recall from the previous video how we added logic in the boundary game object to destroy shots that left the play area. Since nowhere in our logic do we actually check that objects leaving our collider is a bolt, it will destroy any object leaving the play area, and that includes the asteroid. Let's leave it like that. There is no need to keep any object outside of our play area for this type of game. Now, let's make our asteroid appear to tumble. Create a package called Tumble in our asteroid prefab start message handler. We will want to set the rigid body's angular velocity to a random value. Drag the rigid body port inside the Tumble package and select Unity, Unity Engine, Rigid Body, Set Angular Velocity. Our velocity needs to be set to a random vector 3. Drag the vector 3 port out and find under Unity, Unity Engine, Random, the function called getInsideUnitSphere. This will work, but will rotate the asteroid rather slowly. So let's add a multiplier between the random vector 3 and the setting of the angular velocity. Remove the binding by dragging it away. Now drag out the vector 3 and use the iCanScript math scale function and reconnect and clean it up. Let's pull the scale factor to the interface of Tumble and call it Rate. A value of 5 works nicely. Let's test. That looks better. Now, let's make the asteroid react to the objects around it. It should not survive a collision with our ship or getting shot. We will use the asteroid collider to detect when it hits something. Start by adding the message handler on trigger enter, which will be invoked with the colliding object as a component when the asteroid collides into something. We want to action the asteroid colliding with a bolt or the player. We can ignore other cases such as collisions with the play area boundary or other asteroids or enemies. So let's start by checking for bolt and player. Drag out collider info and select Unity, Unity Engine, Collider, Compare tag. Set the tag to bolt. Let's also check for player in the same way. Note how the bolt and player objects were already tagged with these labels. Now, let's create two packages, bolt collision and player collision, as placeholders for the logic required for either of these cases. These will be enabled by their respective compare tags, so create enable ports on these packages and connect them to the compares. Now on every frame for which the compare is true, any visual script inside the package with the connected enable will be executed. For both of these cases, we want to destroy the objects involved in the collision. Let's create a package for this as well. This package should be triggered by either a bolt or player collision. So create trigger ports on both collision packages by right-clicking on them and selecting Trigger Port. A trigger port becomes true upon completion of the logic in the node it is attached to. This is useful for propagating execution between nodes and can be used in conjunction with enable ports. Then, create an enable port on the destroy object package. If we were to connect both triggers to enable ports on the destroy package, it would be evaluated as an AND, i.e. both triggers would need to be true to enable the destroy object package, and this is not what we want. So let's OR them like this. Here we can see our control flow. The red bindings illustrate the execution path that is controlled by our script logic, enable ports, and triggers. Although we may arrange the nodes in a logical up-down and left-right manner, that alone does not define flow, and iCanScript will execute our scripts concurrently in the most efficient manner, unless we implement flow control as we have done here. Now, let's cause some destruction. Using the Library tab, find the object destroy function. Drag two of these in, one for the asteroid and one for the other object. Connect the asteroid component to one. That's easy. For the collided object, we need to get the game object from collider info. Create the collider info instance and using the instance wizard, add an output port for the game object and connect it to the destroy. Let's see if this works. Run the game and drag asteroids into the scene. We can shoot them, and they disappear now. And if they hit our ship, both objects disappear. But somehow this does not look very exciting. Let's add some sounds and explosions. If we look under VFX in the prefabs, we will find explosion effects for both player and asteroid. Let's instantiate these when we destroy the respective objects. We will create the asteroid explosion effect in the destroy objects package. Use the library search to find instantiate. Choose the one that we can instantiate at a chosen position, and drag it into the package. Now, unfold the VFX folder under Project, select Explosions, and drag the asteroid explosion to the original port. What position and rotation should we explode it at? At the asteroid's position. So just drag the transform in, and the instance node. Use the instance wizard to add the position and rotation ports and connect them. Let's do something similar to blow up our spaceship. Using Search under the Library tab, find the Object Instantiate function, the one with position, and drag it into the Player Collision package. Drag Player Explosion under VFX into the port labeled Original. And for this one, instead of using the asteroid transform position and rotation for the explosion, we will use the ones of the colliding object, which would be the spaceship. Just select the Collider Info instance and use the Instance Wizard to add the transform port. Drag this port into Player Collision and add the transform instance. Then add the position and rotation ports to the Collider Info transform port, and connect to the instantiator. Let's try this out. Just drag the asteroid prefab into the scene while running and try to shoot and collide into it. Much better. Now, let's make these asteroids fall without having to drag them in. We will do this in the game controller in the scene hierarchy. Add a visual script component to it. We will instantiate the asteroid in the start message handler. Use a library search to find Object Instantiate. We will have to drop them from random positions, so choose the one with the position as a parameter and drag it in. We will instantiate asteroids, so drag the asteroid prefab from your prefab folder to the port labeled Original. We want to drop them from random points on the x-axis from the top of the play area, so using the library search, find the random range function and drag it in. The game area x-axis is between -6 and 6, so set those values. Now, we need to translate this into a vector 3 for the position. Drag out the position port and select iCanScript, from to, and to vector. Set x to the random value, set y to 0, and set z to 16, which is the top of our play area. We need not worry about rotation since we take care of that in the asteroid object. Let's put this in a package and call it spawn hazard, and pull the position values to the interface of the package. Let's see what this looks like. Looks good, but we will need to drop more asteroids and waves to make this more challenging. We can also see the explosions remaining in the hierarchy. Whenever we instantiate game objects, we need to ask ourselves how they will eventually get destroyed. In this case, while the boundary script destroys our bolts and the asteroids, it does not destroy the explosions because they never leave the play area. For the explosions, we need to do something else. We can destroy them on a timer. For each explosion type, add a visual script. Delete the update message handler and add a start message handler. Using the library search, find Object Destroy and drag the one with the timer, indicated by the T float, into the start message handler. Connect the game object component to the destroy and set the timer to 2 seconds. Repeat for the other explosion types. Let's give it a final try. Perfect. And we will leave spawning more asteroids to the next chapter. Thank you for watching, and please join us in the next chapter of the series where we will continue building the Space Shooter game.